So this is going to be a horizontal version because we can see the foci and the vertices are horizontal. Now the horizontal equation, just a reminder, x minus h squared over a squared minus y minus k squared over b squared equals 1. Just a reminder, that is the horizontal equation. Now, if the vertices are -2 and 1 and +2 and 1, we know the center of the you know what it is going to be in the middle between these. So what's in the middle between -2 and 2?
0.
0. So you could tell your h and k is 0, 1. H, k, 0, 1. Because it's in between -2 and 2. You could also do what's in between -3 and 3. It has to be in the middle. The vertices are always the same distance or equidistant, and the foci is always equidistant. Now, A, what is A? Does anyone remember? It's a distance.
Between the center and each vertex.
And what?
And one of the vertices your choice.
Yes, a vertice. So it's a distance between the center to the vertices. So how far away is the center to the vertices in this one? 2. So it's A equals 2.
What if you do plus minus 2?
Yeah, plus minus 2 doesn't matter. So we found the center of both the vertices, knowing it's in between. A is just the distance from the center to one vertex, which is 2 units. You guys go to left or to right in this case. Okay. The foci, which letter represents the foci if A is vertice? C. So C is the foci. C is going to be plus or minus 3. You can just put plus 3, it doesn't matter. It's technically plus and minus 3, but if you just put 3, you wouldn't lose points. All right. Now, if you notice in this equation, we already have an H, we already have a K, we already have an A, and I identified everything I could from this. I'm going to need to find a B. Good. For this one, though, for hyperbolas is plus. So C squared equals A squared plus B squared, an actual Pythagorean theorem. So 3 squared equals 2 squared plus B squared. A little bit of math. B equals the square root of 5. A little bit of algebra gets you the square root of 5, plus or minus the square root of 5. No, you don't need a decimal. Because when you put it in the equation, it's going to get squared anyway. So it's just going to be 5. You don't really have to do it. All right, since I only ask you for the equation, I don't need the asymptotes in this case. We're not graphing anything. We could just plug in everything we have. And it's horizontal because the vertices are moving horizontal. So the x goes first. X minus the h, which happens to be 0. So actually, I don't put anything. I just put x squared. Am I following that? Over a squared, which was 2, so it's going to be 4. Minus y minus k squared. K was 1, so y minus 1 squared. Over the b, which we found, square that is just 5. Equals, we just need this to be 1, so just put it 1. Yeah. The y minus 1, we get the k value from here, and we know it's 1 because every foci and every vertex is 1. That's at the height of 1. And they are only going left and right, so they have to be all on the same horizontal line in this case.
It's x minus 0, there's no x value now.
H is 0. Do you understand why h is 0? Because if the vertices are here and here, so the vertices at -2 and +2, the middle happens to be 0. Yeah, if it was at 1 and let's say 3, the center would be 2. I'm gonna go to the next page, but if I do that, I have to delete this page. Anyone still need this? All right. Next question. It wasn't asked, so we didn't graph it. You could graph it, but it wasn't asked. All right. Similar question, but what I'm giving you, the information is different. So we're going to have to do different things to find the same information. Give you half a minute to write this down. All right. So equation with a hyperbole of vertices 0 plus or minus 3 with the asymptotes of y equals plus or minus 3x. Now, first, let's just do what we could do easily, which is the vertices. Now, with the vertices being 0 plus or minus 3, that's the same thing as saying 0 comma 3 and 0 comma negative 3. So since the vertices are going up and down, we know ours is going to be vertical because the vertices are going up and down. So our equation is going to end up looking like this as a baseline: y minus k squared over a squared minus x minus h squared over b squared. Remember, hyperboles, the first one is always a squared, and then equals 1. So we know our equation has to look like that. All right. So we should know our vertice is the same distance left above and below the center. So what is the center in this case? If it's between 3 and negative 3, should be 0, 0. So we know the center is 0, comma 0, h, comma k. The center, however you want to label that, is 0, comma 0. Again, we need the A and the B value. We could get the A value because the A value is the distance from the center to the vertice. So what is the A value in this case? 3. Now, typically with this type of graph, always the hard part is B, because B is not a direct thing, usually not graphed. So we need to find B because that's the only thing we're missing. As soon as we find B, we could just put this all together and stop. But we need to find B. C, if C, it helps us find B, sure. But we don't need to find C. If we don't ever find C, it's okay. But what happens here is we don't have the foci, so we can't use a squared plus b squared equals c squared. But we do have the asymptote. Now there's this particular equation for the asymptote. The equation is y equals this is for the B, and this is for the asymptote formula. Did I give you it like this, negative B over A, or did I flip A over B? No, the asymptote. It should be. So what I switch this A and B? Okay. Okay, we'll use that one. Let me actually just copy it down. No, I was about to use another one. Can you simplify this? Not right now.
Like that, is that why you're doing it?
No, there's just another formula that I'm just reading off. But I forgot which one I taught you. So if I taught you this one, I'll continue.
Yeah, but is the other one shorter?
Not really. Okay. See what the book tells me. Actually. All right, so this is the formula for the asymptote. So we need to find B. Now we know the asymptote is 3x. Let's plug in what we actually know. We know k is 0. plus or minus A over B. Oh, actually, we know what A is. A is 3. Times X minus 0 equals Y. Guys, Jacob. So then we're going to simplify this. Wait a second. It's plus or minus 3bx. And it has to equal this thing over here, which is plus or minus 3x. So what must B be? What? 1. So B has to be 1 in order for this to work. If it didn't work like that, you could do some algebra to solve it out. But it is going to be 1. The equation is this one right here. And I just plugged in everything I know. Then I set it equal to the asymptote that was given. And what happened is exactly the same. So I knew it was 1. But if you didn't know, you could just do some algebra. What's up? Mm-hmm. No, because the y and the y here just allows me to substitute to each other. I don't need to find the wall. What about the x? Oh, the algebra would be 3x over b equals 3x. So I would divide 3x on both sides and multiply b on both sides, and you have b equals 1. Okay. So we found B is 1, we found A, we found our center, we found everything we need. In this case, we did not have to find C to help us find the equation. So the final equation, I'll put it right here. The final equation is y minus 0, but you don't have to write minus 0. So I'm just going to put y squared. Y squared over A, which was 3 squared, so 9, minus x minus 0, but you don't need to write minus 0. So x squared over 1 squared, which is 1, equals 1. Go ahead.
What's B in this equation? What's A in this equation? What's Y in there?
Y and x are just variables. Just like any equation, you need the y and x so you can find any point. A is the distance between the center and the major vertice. And we just found that because if this is 0 and this is 3, must be 3 away from each other. And B, we had to use this equation right here because this equation right here lets us have everything but B, and then we could just do some substitution. Anyone needs a sub, so Jacob, you still ready? All right, going to the next one. Everyone try this one. Everyone try this one. Remember, your formula is only missing an H, a K, an A, and a B. So that's the 4 things you only need to look for to make this equation. Usually H and K is a freebie, honestly. The B is usually the hardest part. Think that you have the asymptote like that. What do you got to do? H, K, and A should be easy. B is you have to think a bit. I want you to try that. You guys want me to start or are you still working on it? Anna, you want me to start or are you still working on it? Sarah? All right, so everyone should have gotten these three things easily. The center is in between the two vertices. So between -5 and 1. So that's going to be 3, -2. Your A value is the distance between this center from this vertices, this is H and K. So yours it should be just 3, ±3 if you want. Now the B is the question. How do we find B? Well, I know my general asymptote formula, K plus or minus. Oh, first I should identify, is this horizontal or vertical? Vertical, good. So that's going to be y minus K squared over A minus squared. So the vertices, how are they changing? In the Y's or in the X's? Sarah, how is the vertices changing? In the Y's or the X's? No, they're not. They're changing the Y's. Like the Y is going up and down. Yeah, so that's why. It's going up and down, so it must be up and down. Okay, so for a vertical, is it B over A or A over B? Someone tell me the formula?
K plus minus K over A, open parentheses, X minus H, close parentheses, over B.
I just put it like this. That's I know what you mean. X minus.
But mathematically, that's what it is.
Same thing, yeah. No squared, right? Yeah. Okay. So we have this formula. We also have this thing right here. I'll do in red. Y plus 2 equals plus or minus 2 X minus 3. Now, the only thing that's annoying is that this 2 is here. So I'm just going to move it over here. So Y equals -2 plus or minus 2 X minus 3. No, because this is 2 times all this stuff. So you can't just add them together like that. So I'm just going to put a -2 in front. So we have a situation where A over B, look at this. This 3 matches the 3 over here. This -2 matches the -2 over here. So what happens is that what we have is that A and B, this is the same. We could cancel this out. This is the same. We could cancel this out. Oh, not that part. We could cancel this out and this out. So what we have here is plus or minus 2 equals plus or minus A over B. And we know A is 3. So 2 equals 3 over B. A little bit of algebra. What is B going to equal? Good. B equals 3. I'm going to leave it as a fraction theory of 2 because it's a little easier to square that over 1.5 or 1.5. Yeah. Yep. So we have our B, we have our A, we have our N and H and K. So we could just put it all together. Y minus -2, but the minus a -2 must be a +2 squared. This is the Y and this is the Y, so I just set them equal to each other. Vertical. What's up? What does the Y do? The Y, I just set these two equal to each other, but I just cancel everything out. So do you notice there's going to be a pattern? What's the pattern basically? If you need to find B. Exactly. This number right here, this 2, whatever this number is, whatever that number, we don't have a variable for that. is always going to end up equaling A over B if it's vertical, or B over A if it was horizontal. I always just do it out the long way because I'm overly cautious. So A squared, A is 3, so that's 9, minus X minus H. Oh wait, I actually know what H is. 3 squared over B squared, 9 over 4, or 2.25. Yeah, 2.25. I guess I shouldn't put fractions of fractions. Equals 1. Yeah, yeah. Fair enough. Oh yeah, definitely. It's not irrational or anything. B squared. 9 quarters, 9/4. You put whatever underneath there. I just don't like the idea of putting a fraction in a fraction, but you can put it, if you put 9 over 4, you'll be fine. You put the 4 on top, yeah. Which is not the best for us because we like it in this exact form, just so it's very easy to see. So being the 4 up there is not the best part for us. All right. Yeah. Let me see. I actually don't know. Yes, definitely. Yeah, we'll do that tomorrow. Okay. I'm gonna take some picture. Oh. Here it is. Yeah, dude. I told you we have like a week to review. No, this is the last section. We're gonna do one section that's kind of like tell the difference from the 3, but otherwise then we just stop. No problem. What? Whole chapter, and I want the whole chapter.
Thank you.
Where are you guys going? Is it? Oh, you got 3 minutes. Chill. Sit down. Did everyone spit? Guys, where are you going?
I was just gonna enjoy the. Mitch, you're gonna enjoy the.
That's true. I see it. Keep doing that.
What was he thinking too? There's so many variants of it. Brandon. Yo, Randy. Brandon. That was wild. Brandon, you hurt my eye. Why would you ever send that?